Oh, we are back, baby. Golly, let me move this thing. Guys, we're back. So we're going to talk a little Solidity functions, a little bit of functions. You can't spell functions without fun, all right? So we've learned about how to store values inside of our smart contracts. We got some storage stuff figured out, right? And how it stores on a bit of a lower level. Okay. So we figured out some of that. Now it's time to learn how to read and modify those values. We accomplish this by adding functions to our contract code where we want to manipulate some data and do some things, right? So technically, we already created functions in the previous lesson on data types we did when we did some small summing and things like that by setting our state variables to public. That as well. The compiler was creating a getter function under the hood. Boom, look at that. We can query the value in X externally using a generated function called X and then invoke it with some parentheses. What if we want to modify X though? What if we want to, guys? This is how we're going to do it. We're going to change X. We're going to reassign it. Equals is not equals. So very important to understand, right? Equals is assigning. So we're just saying, hey, this is our first X value. We want to assign it the value of 3. So if we use it anywhere, so far it's 3 until we run this change X function, which will then allow us to call it anywhere in the contract because it's external, and we can reassign the value of X to 5. Let's start coding. Let's dive in. Let's dive. This is what we're here for. This is the fun stuff we're here for, right? So the first function we'll walk through is about a constructor. Constructors get ran on deployment, right? It's like in JavaScript when you first run the server, constructor gets ran with the pager on, right? So I believe constructors with smart contracts get ran when we deploy the contract. So let's double check though. Let's read. Let's get in granularity. Let's get in depth here. Here we are setting the value of a storage variable on the contract's deployment. Is open equal to true? The constructor for Solidity contracts is quite similar to the constructor in classes of many object-oriented languages. Guys, I promise I didn't pre-read this. I promise I did. The constructor function is invoked only once during the contract's deployment and never again. It's generally used for setting up initial contract values. What if we wanted to compute basically initial values whenever we wanted to deploy a contract? Hey, this function better compute some data for us. It's basically like the use effect of functions, if you will. Use effect with a dependency array that just runs one time. So what if we wanted to let the deployer of the contract decide the value of is open? We can pass an argument to our constructor. Let's see that in action. So it looks like the constructor is accepting a private Boolean value of is open. Let's check it out. Now the contract deployer can decide the value of if it's open. Interesting, right? Interesting. So we have a Boolean value of is open. Oops. And we can now declare this new value is open to this Boolean value, this private passed in variable of is open. But it looks like we need to do some sort of public version of this. Well, really, we don't need to do anything, right? We're just kind of working as we want. We don't need to do anything, right? But okay, so this constructor function will get fired off, right? Check it out. Now the contract deployer can decide if the value is open, if it's true or false. That's pretty cool. So notice how the parameter of is open has an underscore in front of it. This prevents the variable from having the same name as the storage variable, just because we named this one is open, so we don't want to confuse it with these two, right? That just convolutes everything. So what we can do is change the name of the variable is open var, and then we wouldn't have to do that. We could do stuff like that, but seems to be that this just makes it easy. Just prepend it with a when the variable names collide, it is referred to as variable shadowing. Who wants to be a millionaire? This is the type of question that would come up on Who Wants to Be a Millionaire. You know what I mean? It's like A, B, C, D. Can I phone a friend? Can I phone Pags for this one? Can I phone my friend Pags? Hey, what is variable shadowing? It's when variables collide because they have the same name. All right, have a good one. Go win your $1 million, right? So it can happen in Solidity quite often since we can refer to storage variables without using this. Let's explore this in further details. Your goal, unsigned, int constructor. Create a constructor which will take the uint as an argument, store this uint value inside a public storage variable called X. Okay, so let's redo this. So we have a uint. Looks like this will be an underscore x, and we want a uint x here. Cool. All right, and this x gets reassigned to the new x. Nice. I think that's what it wants. Let's run it. Let's see what we got. Give me all you got. First take, baby. That's what I'm talking about. Give me all you got. I forget what that's from. So I think it's from this movie called Division 3. It's the funniest movie. Complete tangent, by the way. Complete tangent. But it's this ridiculous movie. It's so dumb and funny. And I think that it's this movie right here. This coach is just like a complete nut. And they have this guy, he's the trainer. He'll be like, this is your nutritionist. This quarter tub of fun is your nutritionist. So it's just a ridiculous, like old, like late, early 2000s kind of just corny, cheesy movie. Just stupid funny. Just ridiculous. And I think there's a spot where he's like, give me all you got. Anyway, back to learning Solidity. Okay, so the contract functions. Beside the constructor, contracts can define our functions or other functions which can be invoked directly by an externally owned account or by another contract. Let's take a look at the Solidity function syntax. We have function, my function, external, do something. The external visibility, so we have these visibility kind of words that we can append onto stuff. We have public, external, view, and private. I believe are all four. There might be one more I'm missing, but okay, so the external visibility specifier allows for this function to be accessed from other contracts or from an EOA. What is an EOA? External visibility. Let's see. Let's Google this real quick. What is an EOA? Blockchain. EOA, externally owned account. Okay, so the most common type of blockchain account that gives us direct control. These accounts are created using private keys. So I imagine these are roughly a wallet, right? Okay, so that's important to know. So the external visibility, or down here, external visibility is quite similar to the public visibility for functions. External is better than public if you know that you are only calling the function externally, outside of the EVM, the Ethereum virtual machine. Public visibility requires more gas because it can be called externally and internally, which complicates the assembly code. Okay, so your goal is to increment. Let's see, we want to increment X. So how do we check the assembly code real quick? I kind of want to muck around with a little bit of assembly, right? So can we do this real quick? Can we see what's going on here? See what this is? Command and enter to run the code. Oh, we don't want that. Okay. All right. Maybe we won't muck around with the assembly code, but okay. So let's build on your code from the previous stage. Create an external function called increment that will add 1 to the state. Oh, is it because we're in a constructor? Is that why? Create an external function called increment that will add, let's see, function increment. We'll take uint x and what's external, right? And it will add 1 to x, right? I guess technically we don't need to pass in a thing. Let's see if that'll work. So let's run it. Let's see. Oh, give me all you got. All right. Sweet. Oh my gosh. This is too much fun. Okay, so returning values. It's time to learn how to return values from Solidity functions. Let's see an example. Contract. Funny name to name a contract. Bool is running. Okay, so we have all of our stuff here. Function is running. Its external view returns a Boolean value of a private variable is running, or a renamed variable is running. The is running function indicates it is returning a Boolean data type within the function signatures, returns bool. Once declared, we can use the return keyword to return a Boolean value within this function. Cool. Adding the view keyword to the is running function signatures guarantees it will not modify state variables. You can think of the functions as read only. I'm going to read that one more time. I'm going to read only that one more time. So adding the view keyword to the is running function signature guarantees it cannot modify the state variable is running. You can think of view functions as read only. You can think of view functions as read only. They can read the state of the contract, but they cannot modify it. Okay, cool. That's good to know. So your goal, add a uint, create an external view function add which takes a uint parameter and returns the sum of the parameter plus the state variable. Golly, okay, let's try. So we built a function add. It's an external view function, okay? And what does it return? It returns, what is it? Is this what we do? We say returns here, I believe. Do we need to do all that? Returns, what did it say? Returns the sum of the parameter plus the state variable x. Okay, so does it needs to take in a parameter then, right? So it takes in uint parameter, we'll say, I guess, number. So function adds some sort of number, right? And it needs to return a uint answer, right? Something like that. Returns a uint value. And then this number needs to, let's say, sum equals number plus x. Let's see if this works, right? So we could return the uint sum of this number. Hopefully this somewhat something went right here. You know what I mean? Hopefully, first take drink, baby. First take drink, baby. Let's go. Oh man, that's awesome. That's a good feeling. That's a good feeling. I'll tell you what, you know what I mean? There's good feelings. That's one of them. You know, when you just absolutely murder a contract function, oh boy, there's nothing like an external viewable only contract function. Come on. Who's doing this? You know what I mean? They sell drugs. You know what I mean? They sell sex in Amsterdam, but program with tags, we sell external viewable functions, folks. There's no better feeling. There's no better feeling. I'm telling you right now. So when developing smart contracts, Foundry makes it super easy to write Solidity unit tests, among many other features. We are using Foundry for code execution in the very code lesson. For that reason, you can make use of the console library for logging console data when you need to test something. Sweet. So this is the Foundry tools. Let's see, that's how we import them. Good to roughly remember. Here's an example of how it's using. So we have a contract C. If condition was met, or if condition, console log condition was met. Okay. In this example, if the condition is met, we'll see the message of the test results. This can be very helpful when you're trying to figure out and debug code. Console logging statements, just little bits at a time. You can do this in any of the Solidity lessons throughout this course. Just remember to import Forge STD console. Speaking of selling sex in Amsterdam, you definitely want to test. At the top of your file. Okay, so your goal, return the secret. There is a message. Oh, you know what? I was going to say something, but you know what? I'm going to keep reading. There's a message being passed to you in the winning number function. You can use the console log display this message to the console. I will tell you what to do from there. We haven't discussed the call data keyword just yet. We'll hit this keyword in the upcoming lesson on the reference types. For now, know that your reference types like string or call data specifies the data location, specifically if it is saying the value is located in that message call data. Okay, so I'm not sure what we still need to do. So the goal here is there's a message being passed into the winning number function. You can console log to display this message. Okay, so was that all we needed? Was just, I suppose, to console log here? Let's see. We did our little semicolons. Okay, so we needed to console log our secret message. Sweet. And it looks like we have a call data. Wait a sec. So display this message. It will tell you what to do from there. Got it. Okay, so we need to display the message. Let's see. See what it does. I just did command enter to run the thing. Return the value 794 to win. Okay, so that will return 794. Let's try. Sweet. I think that worked. Nice. Found it. We found it. We found the secret message. We have found it. All right, guys, we've got a pure double. Here we go. So pure functions. Occasionally there is a necessity for Solidity functions that neither read nor write to state. These functions are labeled as pure. So hold on one more time. So a pure function neither reads nor writes to state. So neither reads from state, neither writes to state. Let's say we wanted to add together two uint values. So is a utility function from like a separate file, is that technically a pure function? Because it's not like associated with a state within that thing. Questions I have. Let's say we wanted to add two uint values. Function double uint x uint y. External pure returns uint. This function is just performing simple arithmetic without reading or writing to state, so we can label it pure. Okay. So it's also worthy of noting that there is an alternative syntax for returning values in Solidity. Got it. All right, cool. So it's also worthy of noting there are alternative syntax for returning these values in Solidity. Got it. So we could return like this, I suppose. We could do like do these both do the same thing? Function double uint external pure returns uint sum. Oh, I see. Okay, that does work. So we can declare the sum that we want to return here. That's the difference. With a return statement, we could do it like this. With no return statement, the return statement I assume is assumed here. Assumeception. Okay, so whoa, that's new. In the returns keyword, we specified the name of the parameter that we wanted to return right here. Boom. Then we assigned it to the x plus y to sum inside of our body function. The value is implicitly returned. That's kind of cool. So we want to write a pure function called double. Okay, not funky town, but function called double. And we want a uint, looks like. Uint parameter, we'll say it's a number, and it returns double it. So what we can do is say, is it an external function? No, it's a pure function. Or is it external pure? Create an external pure function. There it is. That's what it is. Okay, so create an external pure function, and we can return uint here, or we can also do the doubled value. So let's just walk through both real quick. So we could say return number times 2 to double it, right? We got that down. That should pass us, I believe. And then let's do the way that they want it as well, potentially. So that's one way to do it. And then the other way to do it, I suppose, is say sum, assign it to the number times 2. Or better yet, we could say doubled, right? Maybe a more accurate word. I'm doing a Python deal right now, so forgive me. It's in Python casing, guys. Okay, what is going on with this deal? Do you guys see what I'm dealing with there? I have no idea why my keyboard. I'm like trying to. You see what I'm highlighting this, but it's deleting everything, but not the U. What the heck? Okay. Let's just try. So it's like one space over. Like I'm pressing on my keyboard, but it's like one space over. So this is a little weird. So uint boom and boom. Okay, so I think that'll do. So we don't have to return now. We could just it's implicitly assumed here. So I need to give it one less space, I believe. One more. Okay, let's try that. Double number. Uint 256 type is not. Oh, right here. I deleted the int to be uint. Guys, I'm pressing U. Oh, there it goes. Okay. So I don't know if you saw that was weird. So I don't know if it's like typing on the right side. Oh, and that worked. That worked too. So sorry guys, that was a roundabout mess up. That was a bit of a mess up. But the point is we can return it, or we can say doubled number and return it here. So that's how both those worked. I don't know why it was weird breaking the code like that, or writing on the side of the cursor thing like that. But anyway, okay, so we're back in it. Awesome. So overloading functions. I was overloaded on that last function. That's golly, you know what I mean? Golly, a little syntactically overloaded. In Solidity, it is perfectly valid to declare two functions with the same name if they have different parameters. It is perfectly valid to declare two functions with the same name if they have different parameters. Oh, okay, so we have an add and an add, but this one just takes x, y, z. This one takes x, y. Okay. Interesting. I don't know if I've seen that before. I think that would throw an error in TypeScript potentially, would it? I don't know. I'll have to try it. But okay, so Solidity will run the function whose signature matches the arguments provided. So I imagine you have to pass in different arguments. Oh, okay, that is what it's saying. Okay, so it'll just run the one. It knows to run the one if we pass in two variables. It knows it's running this one because it's x and y. If we pass x, y, z, it knows to run this one. Awesome. Also, Solidity can return multiple values from functions, also known as tuples. Sweet. Okay, so notice that a returns keyword specifies two values, so y plus 2 and x plus 2. I said it backwards, but x plus 2, y plus 2. Also notice we are wrapping the values in parentheses in order to return the multiple values. This is referred to as a tuple. Tuples are not a formal type in Solidity. They are a list of values that can be used as temporary structure to return values or do assignment destructuring. The data types of the return value in tuples can be different from each other. We can also use tuples in assignment destructuring. For example, if we have a function called add2, we just defined above, okay, or defined above, but we'd have 6 plus 2, okay, or 4 plus 8, which would be 6 and 10, if you add 2 to both of those. Okay, so, I didn't even realize that. On the left side, that's the destructuring of tuples. That is so cool. Wow, that is so interesting. Wow, okay. So let's see. So create another variable, peer external function. Let's see. Looks like we got one here. This is the one we just wrote. Perfect. Okay. So we have another function that does what this one does, right? So function double uint number, and it takes 2 uint parameters. So we'll say 1, or we'll just say number, I suppose, to keep it consistent with the other one, just to prove the point. And then number 2, right? We'll say external pure returns a uint, and we'll return in this one. We'll do the other one, right? So double both the arguments, and we'll return it as a tuple. So return number times 2, and then we'll say number 2 times 2, right? Number 2 times 2. Sweet. I think that'll do. Different number of arguments in return statement. You guys heard my little video editor go ding ding. Pretty fun noise. Okay, so let's see. Double both of the arguments and return both of them in the same order they were passed in. We just did that, right? Yeah. Different number of arguments in return statement than it returns. Oh, do we need to have it say return a uint here and a uint here? Is that how it works? Oh, cheeky. Alrighty, that's pretty cheeky. For the solution, what is it? Guys, that I think is done. So for the solution, it's possible to double the function. You may need to change the visibility to external to public so that you can call it internally as well. We didn't have to do that, but interesting. Gosh, we're ticking off. We're learning some stuff. That's pretty cool. That is pretty cool. That's pretty cool, guys. Okay, let's go back to this. Run test. We're off. I think that was a great episode. There's a lot of fruit. I mean, that episode, I got questions for Chester. Maybe I'll have a whole just series of Chester questions. Just questions for Chester would be a fun little series. He's a brilliant engineer. So, but yeah, guys, thank you so much for watching. I'll see you on the next one. This is fun. This is awesome. Looks like we're going to be sending some ether next, so it'll be a good time.